Now next we'll come to the next law, that is your Avogadro's law. Avogadro's law. We can see that. The next law, Avogadro's law. So Avogadro's law, what it says is that before moving to the law, let us understand what little bit work the Avogadro did. Alright. Now Avogadro was the first person after whom we came to know about the molecules, the term molecules. Before then what it was said? Before then it was said to be as compounded atoms. If you read the Dalton's atomic theory, you will find it out that the molecules was considered to be as compounded atoms. Like here I said HCl, it was known as a compounded atoms. Ammonia, it was known as compounded atoms. Water, compounded atoms. In this way. So the term molecule was for the first time given by Avogadro only. That you need to understand first. And not only that, Avogadro also distinguished between the atom and the molecule. As a result, he distinguished between the atom and the molecule. What is an atom and what is a molecule? He told us. Atom is the smallest particle of an element that can take part in a chemical reaction. Got it? And it may or may not exist independently. Got it? Atom is the smallest particle. You know this also. Just once more I am saying you. Atom is the smallest particle of an element, got it, which takes part in a chemical reaction. Just now I said you that when you are balancing the atoms in a chemical reaction, what you are balancing? You are balancing the atom. You are balancing the atoms, not the molecules. You are balancing it. So atom is the smallest particle of an element that takes part in a chemical reaction. And it may or may not have an independent existence. That means it may or may not exist independently. In case of inert gases, it exists independently. In case of what you can say alkaline metals and alkaline earth metals, it exists independently, like Na, K, He, Ne, Ar, Kr, Xe, all these are what? They are the atoms. Alright? So they are the inert gases and the what you can say the alkali and alkaline earth metals. So in that case it exists independently. But in other gases like H2, Cl2, O2, O3, P4, S6, alright, they do not exist independently. Got it now? Where it exists and where it does not. So that is an atom. Now what is a molecule? Molecule is the smallest particle of a substance. Listen carefully. This molecule is the smallest particle of a substance that has an independent existence. That has an independent existence. That means which exists independently. What I said, molecule is the smallest particle of a substance and atom is the smallest particle of an element. Like we say an atom of iron, an atom of gold, an atom of sodium, an atom of oxygen, because they are the elements. We never say atom of water, atom of chalk, atom of sugar. Never we say, because sugar, chalk, water, they are the substance. What we say? Molecule of water, a molecule of sugar, a molecule of a chalk. So the smallest particle of a substance is a molecule, but the smallest particle of an element is a atom. I think it's clear now. And molecule exists independently. It has an independent existence. Got it? Next, he said that the number of atoms present in one molecule of an substance or any what you can say element, that is known as atomicity. That is called as atomicity of an element. We'll find it out also. Next, we'll see it in this Avogadro's law only. The application of Avogadro's law, how to find the atomicity, I will tell you. Got it? So here you see when I write O2, what is the atomicity of oxygen? 2. Because one molecule of oxygen contains 2 atoms of oxygen. I said, you know, number of atoms present in one molecule of a particular substance or an element. That is known as atomicity of a gas, we can say that. So we say N2, so it is diatomic. We say O3, ozone, polyatomic. We say that is S6, we can P4. So all these are polyatomic. This is polyatomic, this is polyatomic, we can say that. When we say Ne, it is monoatomic. When we say He, it is monoatomic. When we say Xe, it is monoatomic. We can say that they are monoatomic gases and they are diatomic, triatomic or polyatomic gases in this way. Clear? So atomicity means number of atoms present in one molecule of a substance. That is called as atomicity. So here it is single, here it is double, here it is triple, here it is 6, here it is 4 in this way. Got it? So how we got it? How Dalton got it, Dalton I'm saying, Avogadro, how he got it, we will come to know. In this particular Avogadro's law only I will tell you. Okay, so this was the first work which was done by Avogadro. before giving the Avogadro's law. Now, next is, what is Avogadro's law now? Under the same conditions of temperature and pressure, equal volumes of all gases contain the same number of molecules. Under similar conditions or under same conditions of temperature and pressure, that means when the temperature and pressure remains the same, when temperature and pressure remains the same or it is similar, let us say the temperature is 273 and the pressure is 180 m, that is under STP we consider, or any other conditions it can be, it is not only STP, any other conditions like temperature is room temperature 25 degrees Celsius or 298 Kelvin, we consider that, clear? So any other conditions, so under what you can say, similar conditions of temperature and pressure, equal volumes of all gases contain the same number of molecules. Now what do you mean by that? Suppose we say 1 liter of oxygen contains, let us say, n molecules. 1 liter of oxygen contains. Alright, under same condition, temperature and pressure, 1 liter of nitrogen will also contain the n molecules. 1 liter of what you can say, helium will also contain the same molecules. You can say that. That is what Avogadro's law says. Under same conditions of temperature and pressure, equal volumes of all gases will contain the same number of molecules. So, that how much it is? Let us say 1 liter of oxygen, or here we let us say 5 liter of oxygen. Instead of 1 liter, it is 5 liter. Then it will be 5 n molecules. Here also, if it is 5 liter, it is 5 n molecules. Same thing. So, under the similar conditions of temperature and pressure, under the same condition temperature and pressure, equal volumes, the volume should be the same. If all are 5, 5. If all are 10, 10. If all are 1, 1. That's it. So the volume should be same. Under same, what you can say, volume, the number of molecules will remain the same. Now, not only molecules, it is also true for atoms as well as ions. Alright, the law is being true for. That is what the Avogadro's law suggests us. Avogadro also gave us a number, which is Avogadro's number, denoted by the letter Na or L. Now this A should be small, understood? It should be a subscript. Alright, A should be. What is the value? 6.023 into 10 to the power 23. Now, for your purpose, for the purpose of class 10, we can say that we can take, instead of 6.023, we can take 6 into 10 to the power 23 also can be taken for doing the numericals. But actually the value is 6.023 into 10 to the power 23. This is the value of Avogadro's number, alright, which was given by Avogadro. That means, if you say that what is 6.023 10 to the power 23, that is, let us say that 22.4 liter of a gas, 22.4 liter of a gas at STP, alright, 22.4 liter of any gas at STP, any gas, whether it is oxygen, nitrogen, helium, what you can say, neon, ammonia, HCl, any gas will contain how many molecules? Will contain this many of any gas at STP will contain this many number of what? Molecules. Now why it is 22.4 liter? Because 22.4 liter is the molar volume of a gas. When I will teach you mole, I will say you that is the volume of 1 mole of any gas. You will come to know what is mole, at that time you will come to know. So in this way, from there we got this particular value, we can say that. So remember it, this is the value of Avogadro's number, 6.023 into 10 to the power 23, which was given by Avogadro under doing some experiments. Okay, fine. That is not there in your syllabus now. Now this is your Avogadro's number. This is a symbol of Avogadro's number. In certain books, N instead of Na we also write it N naught. Naught means degree sign. Alright, we can say that. Clear? But for your purpose, you instead of writing 6.023, you can write it as 6 into 10 to the power 23. That also can be written as Avogadro's number, we can say. I think you understood what is Avogadro's law. Equal volumes of all gases under same conditions, under similar conditions of temperature and pressure, contain the same number of molecules. That you need to understand. When the volume will remain the same and temperature and pressure is the same, then the number of molecules is also the same, or number of atoms is also the same, or number of ions is also the same. That you need to understand it. Okay. Now, next is, you studied in class 9 about relative atomic mass and relative molecular mass also you studied. Let me tell you about it also a little bit. Relative atomic mass means that is nothing but atomic weight, and relative molecular mass means is also molecular weight of a substance, we can say that. Atomic weight and molecular weight. Alright. Now, generally atomic weight and molecular weight, they are the fractional number, but when we express in grams, it is a whole number. So, generally the value which you are writing it, isn't it? The value which you are writing it, like if I ask you what is atomic weight of hydrogen, it is how much? 1. 1 what? 1 gram per mole, we can say that. Alright, similarly, if I ask you what is atomic weight of oxygen, you will say 16, it is 16 gram per mole. So it is expressed in grams. But when you are calculating, listen carefully, the atomic weight or the molecular weight, it is not a whole number, not necessarily. In most of the cases, it is a fractional number. Then what we do for our calculations, alright, to make our calculations easier, we convert this into grams. And we say it as gram atomic weight, GAM, or gram molecular weight, GMM. So gram atomic weight and gram molecular weight is a whole number. What we do? We convert it into the nearest whole number. For example, as I was saying, that atomic weight of what you can say aluminium is 27, isn't it? It is. Atomic weight of aluminium is 27. But actually, now this 27 what? 27 gram per mole. Understood? It is. When you study mole, you will understand it. What is mole? Then will say you just let me write the unit, or simply you can write gram also. No problem. Now, actually, the relative atomic mass of aluminium is 26.98. For hydrogen, we write it as 1, isn't it? 1 gram. But actually, the relative atomic mass of hydrogen is 1.008. Now, when I write 1.008, it is what? This is nothing but U, AMU. This is U. The unit of RAM, relative atomic mass, is U. U means what? AMU. Rather, I should say U is read as Unified Atomic Mass Unit. AMU means what? Atomic Mass Unit. Unified Atomic Mass Unit. That is the unit of what you can say relative atomic mass. Alright, to calculate the atomic mass or the molecular mass, we use the unit U. But this is a fractional number basically. So what we do is that we convert it in the nearest whole number. The nearest whole number is 1, we can say. Here the nearest whole number is 27, we can say. You are ready in maths. If the number is more than, the decimal part is more than 0.5, then it is converted in the nearest. And if it is less than 0.5, then the nearest lower one. Alright, and if it is exactly 0.5, it is kept as it is. Like chlorine, 35.5. Alright, but actually the atomic mass of chlorine is how much? 35.543. But we are taking it as 35.5. Understood? So you have studied about relative atomic mass and relative molecular mass. You studied in class 9. What is relative atomic mass? I said you, that is mass of one atom of an element by mass of 1/12 of an atom of carbon. Relative molecular mass is mass of one molecule of a substance by mass of 1/12 of an atom of carbon. Atom of carbon, mind it. In both the case, denominator is the same. Again, I repeat. Relative atomic mass is mass of one atom of an element by mass of 1/12 of an atom of carbon. 1/12 of an atom of carbon. Alright, mass of 1/12 of an atom of carbon. Alright, relative atomic mass. Clear? Mass of one atom of an element by mass of 1/12 of an atom of carbon. Relative molecular mass is mass of one molecule of a substance. Listen carefully. Mass of one molecule of a substance by mass of 1/12 of an atom of carbon. Because 1/12 of an atom of carbon is taken to be a standard width. Why 1/12? Because atomic mass of carbon is 12. So when I say 1/12 means 1/12 into 12, how much it comes? 1. It comes 1. For that reason, the denominator is always 1. But initially, we used to take hydrogen in the denominator. Means the definition was mass of one atom of an element by mass of one atom of hydrogen. Or mass of one molecule of substance by mass of one atom of hydrogen. One atom of hydrogen, what is the mass? 1 mu, or 1 gram, we can say that. But why did we change? Because with hydrogen, lot of difficulties was involved. Hydrogen is an inflammable gas. Hydrogen is explosive in nature. When it comes in contact with oxygen, explosive in nature. Hydrogen does not exist in the PO state. It's not available in nature. It's not available in the PO state. Got it? So generally we have to prepare hydrogen. And when we prepare hydrogen, we have to remove the impurities, and it's not easy. So for all these difficulties, and it's very difficult to store also hydrogen, because it's a gas, it's difficult to store. And difficult why? Because if it leaks the gas, then what will happen? It will come in contact with oxygen, it will cause an explosive mixture. So for all these reasons, hydrogen was being discarded and carbon was taken. Carbon easy to store. Carbon means what? Coke, koila. It is easy to store. Alright, it does not react under any substance under ordinary conditions. It is readily available in the pure state. We can say that it is solid, it is not inflammable, it is not explosive. Alright, so all these reasons we took carbon, you can say that, because the advantages are being there. So understood, these all things you studied in class 9, relative atomic mass, relative molecular mass. Just I said it because I said that because this will be used now. So if your idea is not clear, I made it clear, this particular one. So generally relative atomic mass is not a fractional, it's not a whole number, it's a fractional number, it is measured in mu, but we convert it into gram so that it gets converted in the nearest whole number. Alright, it gets converted in the nearest whole number. Mind it? So in this way, this is a relative atomic mass and relative molecular mass and Avogadro's law. Thank you.